I really like Deathloop. I've already talked about this before in the PlayStation 5 video, but I feel that same way about the PC version. I think it's a good version, or at least good enough, but I've heard the alarm bells across the web of people having trouble getting Deathloop to run as they please on their PC. I have heard you. This video is going to be a public service announcement of sorts about how you, yes you in the audience, can get Deathloop to run well enough on your PC. In doing so, I will compare the PC version of Deathloop to the PlayStation 5 version with exact settings to show what optimized settings are really all about and what you need to look out for. But before we get into that, I need to get the important thing out of the way. Is Deathloop stuttering? The technical answer is generally no. If you play Deathloop at a locked 120, 60, or 30 FPS, the game can fly. Here's the game being played at PlayStation 5 settings on an RTX 2060 Super targeting 60 FPS with dynamic resolution up to 4K. It looks excellent and almost will never miss a beat. As far as I can tell, if you use dynamic resolution, Deathloop will have pretty clean frame times and is not too heavy on the CPU. If performance is fine even with the mid-range, what is actually the problem? There are two answers here. The first of which is that at launch, the mouse movement for the camera in Deathloop has been wrong, but a beta patch may help alleviate some of these issues. But let's talk about how the game is at launch. Check out this recording of a mouse moving at 60 FPS in a 60 Hz container. The game is running at a flawless 60 FPS. Usually when doing simple, smooth pans of the mouse here, we would expect a linear movement speed where the world objects that the camera is moving over move at a similar distance with each frame. Here, if I slow down the footage, it's possible to see that this is not the case in Deathloop. Pay attention to the background geometry here on the beach, like the cliff buffs or the bunker. Notice how they move rapidly in short bursts as the camera pans over them, instead of in a consistent linear manner. This isn't the behavior we expect. The behavior though at 60 FPS and 60 Hz is subtle. You may not notice it, but if you go above 60 FPS, the behavior is amplified. Now let us look at 120 FPS in a 120 Hz container. Here the game is running at a flawless 120 FPS. If we slow down the footage, we can see how every 14 frames or refreshes, the camera movement stops. The game graphics are still being rendered, which is why there are subtle differences in the image if you were to look, but the camera movement is stopping every 14 frames with a mouse at 120 FPS. This produces the look of the game stuttering, but it's not performance stuttering due to the GPU or CPU not being able to produce 120 frames per second, rather the camera animation when using a mouse. Now let's look at a value that is not 120 or 60, instead with 100 FPS at 100 Hz. 60 does not divide properly into 100 FPS, so we're looking at a different divisible frame rate here. Once again, I'm running the game at a flawless 100 FPS at 100 Hz, so each refresh is a new unique frame. The issue that happens at 120 FPS manifests differently when the frame rate does not divide evenly with 60. Here the game camera at 100 FPS does not stop, but every 5 frames it increases its speed dramatically for 1 frame and has this frame have an extra large distance in the mouse movement for the camera. This makes the camera movement look inconsistent, non-linear, and it looks subjectively jittery, as one might say. This behavior that I'm showing here at 100 FPS with VSync on at 100 Hz is something users will also see who have VRR monitors like G-Sync or FreeSync when the game is not running at 60 FPS. If you are used to playing games with VRR on with no frame rate lock, this is why Deathloop looks like it is stuttering on your PC when you're not running at 60 FPS. This is the issue that I found, and I think the one that everyone is seeing and reporting as stuttering. The second issue is why I said Deathloop is generally not stuttering. Out of all my hours of play, which are now on Steam totaling about 40, I noticed that 2 times so far that when I loaded up a new map, the game had an issue where every 600 frames would be a redundant frame, causing every 600 frames to have essentially a small, real stutter. This is another issue that may happen to you and why you may be seeing what is called stutter, and this can be remedied just by restarting the game. So after this happened to me the first time in all these hours of play, I tried to reproduce it by playing a full loop on the RTX 3080. On the RTX 3080, while playing through each level and loading the next level thereafter, on the first 4 levels, I was not getting this issue. When I loaded into Uptim at Night though, the issue started as soon as the level was done loading. When I finished Uptim at Night and started a new loop, the issue corrected itself and disappeared. So it would seem that it happens occasionally, sometimes when a new level is loaded, and it can persist through the entire duration of a level, but beating a level and loading a new one can get rid of it just the same as restarting the game can. I think the thing that most people are describing as stutter, people are usually reporting on, are the mouse issues, which do not look good, and something Arkane really needs to fix for this game on PC, and fix it they hopefully shall, because as of the publishing of this video, a beta patch has been added to Steam that you can access by typing Juliana shot me into the challenge field. With this patch, it appears that the 60 FPS inconsistent movement and the 120 FPS 120 Hz camera stoppage is no longer happening with the mouse movement in Deathloop. 100 Hz and 100 FPS though still seems to have that hyper acceleration every 5th frame behavior. So if you're using a VRR display, you will still have issues on non-60 or 120 FPS presentations in Deathloop, and Arkane still needs to look out for a fix. This other issue that I only experienced twice, where every 600 frames reproduced a redundant frame, seems a bit rarer, but at the same time still needs to be something that needs to be fixed, as it really should not be happening. So that's what needs to be said about stuttering, and let's move on to optimized settings. How can you actually get the best out of a mid-range GPU in this game? The way to optimize settings is simple and easily demonstrated when we just look at the PlayStation 5 version of the game. The PS5 version in its performance mode runs at a dynamic resolution 4K targeting 60 FPS, and it tends to actually be around 1296p to 1440p, but it'll go higher in moments of laxity when not too much is on the screen. It can also dip lower close to 1080p when things really heat up. The disparity in resolution between the lowest of around 1080p to the highest at around 1620p or even higher shows that Deathloop has a very variable GPU load. So that means on PC, if you were to just target a flat resolution like 1440p, you would need a GPU with sizable headroom to maintain a flat frame rate at all times. That is why my recommendation for optimized settings, regardless of your frame rate target, is to always use the dynamic resolution setting in-game like you see here, and have it target your VSync frame rate set to the performance mode. This allows the game to always be scaling the resolution to hit your frame rate target and maximize image quality the entire time. It's an intelligent way to get good performance out of this game, as the dynamic resolution scaler in this game is extremely reactive and is changing all the time if you use this performance mode. It essentially leaves a bit of headroom on your GPU, running the GPU at around 90% utilization and adjusting the resolution within that headroom to make sure the utilization is consistent. The next thing to look out for optimized settings are making concessions from ultra settings, just like the PlayStation 5 version does. Let's start with the most expensive options. Ambient Occlusion. The PlayStation 5 in its visual quality or performance mode uses the balance setting for CACAO. The quality setting for CACAO at the same resolution produces honestly a noticeable striation pattern on geometry at times not found on the PlayStation 5 version. The reason why the PS5 would do this makes sense. On an RTX 2070 Super at 1440p, we can see how going from quality to balanced CACAO increases the performance here by 6%, and it honestly looks the exact same almost. HBAO Plus adds a bit more ambient shadowing and occlusion than CACAO does on all modes, but it also costs more GPU, and our optimized settings here are all about being fast like the PlayStation 5. Another optimization is in model detail. The PS5 version runs the model detail at high, making the level of detail at a distance lower, like you can see here on this little car in this scene here, or it reduces the draw distance of objects in the distance, like the grass and rocks at a distance here. This makes sense. The performance increase from ultra to high is 4.5% on an RTX 2070 Super at 1440p, another good optimization. Then you have water detail. PlayStation 5 uses the very high setting for water. This can be seen in the lesser amount of ray march steps in the screen space reflections on water like we see here, as well as in other things like the distance at which ice has deformation and 3D on it in the water like we see here. Going down to very high from ultra increases performance with nearby water by 2% on an RTX 2070 Super at 1440p. The last setting that PlayStation 5 degrades in a way that has a significant effect on performance is motion blur. Here PS5 looks to be using the medium motion blur setting, which I found to have a 2 to 5% performance increase depending upon how much motion blur tends to be on the screen. Medium motion blur is also coincidentally the value that the game starts up with on any hardware out there. The other optimizations that I found the PlayStation 5 version have very little impact on performance in my testing. For example, the shadow option on PC only changes visuals when you go down to medium, which decreases the shadow quality on outdoor shadow maps. But the performance effect of that is extremely small in all of my testing. So here, high or ultra goes. Another setting with little performance win is that for terrain. PS5 uses the high terrain setting here, and this controls the distance at which parallax maps render in. There's not really a measurable performance difference here though. The last setting is decals, but this setting only has in-the-moment performance impacts, and it depends on the amount of bullets, essentially, that have been shot in a combat scenario. It's impossible to really measure performance for, but I've noticed that the PlayStation 5 has a similar decal fade time and decal amount as to the ultra setting on PC. In the end, our optimized settings based on the smart cuts that we found in the PS5 version increase performance by 31% almost over straight ultra settings with quality CACAO at 1440p on an RTX 2060 Super in this scene. I think that's not bad. With these PS5 settings, we can gauge PC GPU performance next to PS5 in its visual quality mode, where the PS5 is essentially always dipping below 60 and is almost always at its minimum resolution of 1836p. By forcing the game's dynamic res to bottom out at 1836p with the frame rate target on PC while using PS5 settings, we can see on the Nvidia side that the PlayStation 5 has performance in between an RTX 2060 Super and an RTX 2070 Super. On the AMD side of things, the PS5 has 10% higher performance than an RX 5700. And this actually lines up pretty well with what we usually see an RX 5700 XT performing like. While PS5 is a great base for rasterized optimized settings, we unfortunately can't use the PS5 for optimized settings with ray tracing, as the PS5 is using RT settings that cannot be matched on PC. For example, ray trace shadows on PC, when at the same output resolution as PS5, look like this, while on PlayStation 5, there's a large alias in the shadow that is not present in the PC settings. Same with ray traced ambient occlusion, where in this scene, for example, even at the same output resolution as PS5, the RTAO in the shadow here, and the way it's filtered, produces a blurry resolve that is not possible on PC. So it seems like the setting is lower on console. But even with that in mind, it's possible using the game's DRS on something like an RTX 2060 Super to have a better locked 30 FPS and better image quality while using ray tracing than one can experience on the PlayStation 5. The performance cost of ray tracing on PC is not too heavy exactly. Turning on RT shadows by their lonesome, which also turns on BVH building by the way, costs 12% performance over sun shadow maps. If something like RTAO was already on though, and the BVH is already being built, then RT shadows will actually add very extra little cost. RTAO is also cheap, at least in its performance mode. The performance mode lowers the resolution and causes some artifacts in areas like the grass you can see here. Interestingly, on an RTX 2070 Super at 1440p, this RTAO performance mode being turned on costs almost the same as turning on CACAO or HBAO Plus, while also looking a heck of a lot better, I would say. Looking at the performance cost across vendors with the RTX 3080 and RX 6800 XT, they both have an extremely similar performance with PS5 settings at native 4K. Turning on RT to its highest adds an additional 7.2 milliseconds of rendering time on the RTX 3080. On the RX 6800 XT, turning on RT under those same conditions adds 11.2 milliseconds of rendering time. So we can see how there's a disparity here between AMD and Nvidia GPUs and how they're burdened by RT. Altogether, based upon my info, my optimized settings look like this. If you're foregoing ray tracing, use the settings that the PlayStation 5 uses, and there's a reason why the devs want the PlayStation 5 using these settings, to maximize performance and resolution. If you're going to use ray tracing, well, use the shadows and the AO, but only use the performance mode for ray traced ambient occlusion. A big part of my optimized settings is leaning on dynamic resolution, which I find to be excellent in Deathloop. Now beyond optimized settings, everyone also has settings for textures, which are going to be different based upon your user preference and kind of your GPU VRAM amounts. The way textures work in this game can be shown off by looking at how the PS5 version looks. Here the PS5 version on close inspection uses the very high settings for textures, quite obviously so, but at the same time, due to its limited RAM pool, much like a GPU, it has to stream textures in when they get closer to the camera, like here in the shot I showed off earlier of shadows in the distance. Notice how the texture resolution here on PlayStation 5 is lower actually than the very high setting on an RTX 3080, which has 10 gigabytes of VRAM. In my experience, going over the VRAM budget in Deathloop does not cause stuttering like you can see in other games. Rather, it causes textures to stream in more often closer to the camera, like here on the RTX 2060 Super with its 8 gigabytes of VRAM. Here the textures are set to very high, and as I round this corner here, notice how the texture pops in here on the bin. This is the kind of behavior you will see if the game is going over your VRAM budget and telling you in the menu. This streaming of textures into limited VRAM pools has a cost on performance that will scale with memory bandwidth as well as your VRAM pool. I was able to measure around a 4.5% performance loss when using the highest quality textures versus the lowest quality on an RTX 2070 Super at 1440p using PS5 optimized settings. I imagine that this cost could get higher if VRAM is more pressured, like at higher resolutions, or if ray tracing is on, which will also compete for VRAM resources. In my opinion though, very high textures are worth it on GPUs like this one, even with this small performance cost. When using these optimized settings, an RTX 2060 Super, like I said earlier, on a Ryzen 3600 can manage 60 FPS at a dynamic 4K. Yeah, it's going to be between something like 1296p and 1440p rather often, but I still think it looks good enough for the power of this GPU. On something like an RTX 3080 on the really high end, playing with PlayStation 5 settings allows 4K 60 to be brought into the table at native resolution, where here without VSync on, it's possible to be seeing how the frame rate is generally in the 70s or 80s and only dipping down to the high 60s at its worst. When using optimized RT settings, an RTX 2060 Super can play the game at dynamic resolution 1440p, managing a proper 60 FPS with all the action on screen, where the dynamic resolution usually finds itself around 1080p. An RTX 3080 optimized RT settings can do 4K 60 and manages to look awesome and run awesome at the same time. Here in all my play on the 3080, I did not record any drops, and I had the dynamic resolution slider set to DRS quality mode, which can only drop down to 1836p. And with that, we've reached the end of the video. Deathloop's issue is primarily its erratic mouse movement. Beyond that, I did find small and rare evidence that the game can have a periodic stutter that goes away when you restart the game. So Arkane need to fix those as soon as possible, as the game honestly should not have these issues, especially the mouse issue. Other than that, I actually find the game scales well on the GPU and CPU. With optimized settings, you can get an awesome experience here, presuming that the other issues do not get in the way. But that's enough for me for now. If you did like this video, hit that like button and subscribe to the channel. If you're already a subscriber, then hit that little bell in the corner to be informed as soon as Digital Foundry posts a video. If you want to help us out, support DF on Patreon to get years worth of our content available in high quality for download. If you want to talk to me about Deathloop PC, write a comment below or follow me and DF on Twitter. And as always, this is Alex bidding you farewell und auf Wiedersehen.
It's cold and weird.